Today I'm going to talk about the review of the basic semiconductor device. So let's start. First, let's talk about the basic concept of transistor. This is the basic schematic of the transistor. So this this schematic means source, gate, and drains. And actually, the transistor has four terminal at because of the substrate, but I didn't write a substrate in here. But actually, this the under the drain and source, the every part is the substrate. So actually, there are four terminal is located in the transistor, and um, we put some voltage in the source, gate, and drain. Sometimes we put some voltage on the substrate, but it means a backgate. But actually, um, normally we put some voltage on the source, gate, and drain. And actually, when we put voltage on the source and gate, yes, actually, when we put some voltage to the transistor, current will flow source to drain. So electron moves and then the current will flow in here. So we calculate the VT and make some voltage drop in the source and drain. So we make the current flow in here. So actually the transistor works like that process, and this is the current curve of the transistor. So before the VT, this is the threshold voltage. The current go up very slow, not slowly, but going up until the VT. And after the VT, the current flow very like a on state. This is before the VT. This is the off state of the transistor. So current flow very low, but actually after the VT, the current flow very good, and this is the a real current flow in the transistor. So we draw a curve like this, and this is the quantum mechanics of the electron. And actually everything in the transistor made by the atoms, so we should know about the quantum mechanics. So there are two concepts of the quantum mechanics. So energy quantization. So every energy can be quantization its state. So we can draw a graph like this, and then second concept is the quantum tunneling. So electron or hole, like the quantum can move the walls. So this is the basic concept of quantum mechanics. So we should know about this concept, and also can use the device calculation. So yes, and then we make yes, and also we can talk about the hydrogen molecules. This is the very easy example of the quantum mechanics. So I take this example. So actually we should know about the energy characteristics. So energy is the low thing. energy state at 2 energy state, it gonna be lower than before. So we should know about the characteristic of energy state. So if the more energy state will be if the more energy state are added together, the energy state will be lower and the maximum energy state will be lower and lower. So we should know about the basic concept of that. So and then let's talk about the conduction band and valence band. So conduction band and valence band is the most important characteristic of the energy diagram in semiconductor device. So insulator means electron cannot move, electron and hole cannot move each side. So because of the forbidden gap, the middle side of the band is very far. So conduction band and valence band is so for each other. So the electrons cannot move up to the conduction band because they don't have enough energy in here. So they don't have enough energy to move up to the conduction band. So current cannot be flow in here, so we called it insulator. So this is the first concept of the energy band diagram of insulator. And then second means semiconductor, that we actually know the important, it is very important for us. So this is the just like semi. So if the electrons have enough energy to go up, moving up to the conduction band, jump up to the conduction band, they can jump up to conduction band. But however, they don't have enough energy to jump up, they cannot current cannot be flow. So how much energy to be put in here, the current can be flow or not flow. So we can adjust the current flow. So this is works like semiconductor. And actually metal has no forbidden gap. So actually conduction band is very near to the valence band, or yes, so any time, every time the current can flow very well based on very low input voltage. So that energy diagram gonna be looks like this. And this is the material characteristic of the semiconductor material. So there are 3 states in here: crystalline and polycrystalline and amorphous. So this is those 3 types material structure can be shown. And then crystalline is very elaborate, so current can flow very well. So because their grain is very comfortable, so there are no grain boundary in here, so electron can flow very well. But polycrystalline is like a semiconductor, so they have grain boundary each side, but that's okay because the flow of current is slower than crystalline, but also the current can flow well in here. However, amorphous has no specific structure in here, so current cannot flow very well, but uh, some of the material, the structure characteristic is like amorphous, so we also know about the basic concept of the amorphous structure. And this is the energy band diagram of PN diode. So the left side is the forward bias when we put the forward bias in here, and right side is the reverse when we put the reverse bias in here. So actually we put some forward bias in here. The depletion reason will gonna be short, short than before. So energy and also the potential barrier, like a built-in state, we called it built-in state. Built-in voltage gonna be lower than before, so everything makes the current flow, electrons and holes move very well than before, so the current also gonna be very flows well. Then after, when we put the reverse bias in here, the depletion reason gonna be bigger than before, and also the built-in potential, like a potential barrier, gonna be higher than before. So when the electron want to down or gonna be up, move up, the carrier cannot move very well than before, so the current flows lower than before. Then let's talk about the MOSFET characteristic of. So this is the basic capacitor CV curve of the MOSFET. So the boundary of the MOSFET, like between the gate and substrate, there is a oxide material in between them. So because of the oxide material, that device structure can work like a capacitor. So when we put some voltage to the gate and, well, drain and source, actually first the carriers accumulate on the boundary, like between the gate and substrate. So many carriers accumulate on there, and then they lose their own characteristic because of the carriers. So we called it depletion reason. And then after the depletion reason, the more and more carriers will be accumulate in the boundary. So the origin material lose their own characteristic, so their characteristic gonna be changed. So we called, when the material's characteristic changed, we called it inversion mode. So after the inversion mode, the channel will be made in there, so the current flows in there. So today we talk about the review of the semiconductor device basic concept. So thank you for watching my video. Bye.